Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET preparation, we'll be looking at previous year questions of physics and medical entrance examinations in India. Today we're looking at the chapter Laws of Motion. This is one of the most important chapters in the grade 11 syllabus for physics in CBSE, and this chapter is the fourth chapter in that syllabus. So today we're here with some questions which are very important as well as simple. So we expect that you watch all of the videos, all of our videos, and also the entire video so that you can get a complete and comprehensive idea of questions asked in this chapter. So let's look at our first question. A molecule of mass m of an ideal gas collides with the wall of the vessel with the velocity v and returns back with the same velocity. The change in the linear momentum of the molecule will be. So, in this question, the same molecule collides with a wall and it comes back with a velocity which is v. So it hits the vessel with the velocity v and returns back with the same velocity. So in this collision, mass and velocity are same in magnitude. You can never say the velocity to be same because over here the velocity is projected in opposite directions. So therefore the mass and velocity are same with respect to magnitude, and velocity differs with respect to direction because the direction of both the velocities are different. So you need to find the change in the linear momentum. So momentum is expressed as mass times velocity. So therefore initial velocity can be written as m times v, and also final velocity can be written down as m times v. However, since v is in the opposite direction, we will write minus before m. So p initial is mv and p final is minus mv. In order to find the change in momentum, that is delta p, you subtract p final from p initial. So p initial minus p final gives you delta p. So mv minus of minus mv gives you 2mv, which is the correct option, which is the correct answer for this question. So therefore option C is the correct option. Now let's look at the next question. If the force on a rocket moving with a velocity 500 meters per second is 400 Newton, then the rate of combustion of the fuel will be 0.8 kilogram per second, 10.8 kilogram per second, 8 kilograms per second, and 1.6 kilograms per second. So how do you write force? Force, according to Newton's second law of motion, is written as the rate of change of momentum. So F is equal to dp divided by dt, Newton's second law. So how do we write momentum? Momentum is written as mass times of velocity divided by dt. So the change in momentum divided by change in time gives you force. Now, in this particular question, the object is a rocket, and when rockets propel satellites towards space, they have the same velocity, they maintain a constant velocity, but because of the combustion of fuel, the mass will differ. So F can be written as v times dm by dt, and this dm by dt in the question is the rate of combustion of fuel. So in the question, force is given to be 400 Newton and velocity is given to be 500 meters per second, and the rate of combustion of fuel is dm by dt. So therefore you can write dm by dt as 400 divided by 500. So 2 zeros get cancelled, so you have 4 divided by 5, and 4 divided by 5, when you do the division you get 0.8, so 0 becomes 40. 5 times 8 is 40, so that is 0. So 0.8 kilograms per second is the correct option. So the correct answer is 0.8 kilograms per second, which is option A. So among the following, option A is the correct option, and we used Newton's second law in order to solve this question. The condition being that we use dm by dt instead of dv by dt, because in a rocket the velocity is constant and the fuel is consumed as we move further towards the atmosphere. Next question. A rocket engine lifts a rocket from the earth because hot gases push it against the air with very high velocity, push it against the earth with very high velocity, heats up the air which lifts the rocket with very high velocity, react against rocket and push it up with very high velocity. So this question is basically an understanding of Newton's third law, and the famous third law states that every action has an equal and opposite reaction. Now, this law is valid under a very specific condition. The condition is that action and reaction, the forces, are present on different surfaces. So therefore, option B can be given as the correct option, because over here the hot gases push on the earth and the earth pushes against the hot gases, so therefore that enables Newton's third law of motion to work, and therefore option B gives us the right option. Pushing it against the air is not the correct option when lifting a rocket from the earth, so option A is incorrect. Option D, react against rocket and push it up with high velocity, is only partially true. The most appropriate option is option B. So heating up the air which lifts the rocket does not work, because that does not involve Newton's third law. So option B is the most appropriate option for lifting a rocket from the earth, because hot gases push against the earth and the earth pushes back on the rocket. So if you have a rocket, the earth pushes against the rocket, and the rocket experiences the force which enables it to lift up from the earth. Let's look at this question. A 1 kilogram particle strikes a wall with a velocity of 1 meters per second at an angle of 30 degrees, and it reflects at the same wall in a time period of 0.1 seconds. Find the force exerted. So in this question you can see that on the wall the object of mass 1 kg and velocity 1 meters per second undergoes elastic collision, so its velocity remains the same, and therefore, and also the angle of reflection is equal to the angle of incidence, so therefore the cos component for both velocities will always be cos 30. So in order to solve this question, we take the component of velocity along the horizontal axis, which in this case is v cos 30. So here the initial momentum is the mass times v cos 30 degrees, and P final, it is mass times minus v cos 30 degrees. So rebound of the particle depends only on the cos component of the velocity, and that's why we take the cos component to find out the momentum of the particle. So delta P, that is change in momentum, can be written as mv cos 30 degrees minus of minus mv cos 30 degrees. So therefore mv minus mv will be 2mv. So it's similarly mv cos 30 minus of minus mv cos 30 gives you 2 times mv cos 30 degrees. So we can write delta P as 2 times the mass, which is 1 kg, times the velocity, which is 1 meters per second, times cos 30, which is root 3 by 2. So 2 and 2 gets cancelled, so the value of delta P is root 3 kg meters per second. Now, according to Newton's second law, force is equal to dP divided by dt. dP is equal to delta P by, so dP is equal to delta P, dt is equal to delta T. So change in momentum is root 3 divided by the time period given is 0.1 seconds. So that will be 10 root 3 Newton, making option D as the correct answer. So 10 root 3 Newton is the value of the force exerted by the particle and experienced by the particle. So therefore option D will be the correct option. This is the next question. A gun fires a bullet of mass 50 grams with a velocity of 30 meters per second. And due to this, the gun is pushed back with a velocity of 1 meter. Then you need to find the mass of the gun. So this question uses conservation of linear momentum. So the formula is m1u1 plus m2u2 equals m1v1 plus m2v2. So in short, total initial momentum is equal to total final momentum. So initial momentum will be 0 because both the gun and the bullet would be at rest before firing the gun. So 50 grams times 0 plus m2 times 0 will be equal to, the right hand side will be 50 grams can be written as 50 by 1000 times the mass, times the velocity of the bullet is given as 30 meters per second, plus m2 times the velocity of the gun is given as 1. So therefore 50 into 30 divided by 1000 plus m2 gives you 0. So the zeros gets cancelled on the fraction. So therefore 5 into 3 is 15 divided by 10 plus m2 is equal to 0. And since mass is scalar quantity, you can write m2 as equal to 15 by 10. That is equal to 1.5 kilograms. So therefore option A, 1.5 kg, will give you the correct option. Now if you're taking the actual formula, then m2 would be given as minus, but since mass is scalar, you do not take the negative sign. So therefore the mass m2, that is the mass of the gun, is equal to 1.5 kgs. Let's look at this question. When two surfaces are coated with lubricant, then they will A, slide upon each other, B, stick upon each other, C, roll upon each other, D, none of these. So when two surfaces are coated with the lubricant, what happens is that they have reduced friction. So friction is the force that opposes relative motion between two surfaces. And the relative motion between two surfaces is commonly referred to as sliding. So therefore, option A, slide upon each other, will give you the correct option. Option B, sticking to each other, is incorrect because that depends on the nature of the lubricant. And option C, roll upon each other, is also incorrect. Rolling has rolling friction, and when you're coating the round surface with a lubricant, then it slides instead of rolling. And since you can slide two surfaces against each other when you're coating them with a lubricant, option D, none of these, will also be incorrect. The right answer is option A, slide upon each other. This is the final question of this episode. The velocity of a bullet is reduced from 200 meters per second to 100 meters per second while traveling through a wooden block of thickness 10 centimeters. Assuming it to be uniform, you need to find the value of retardation. Now, retardation is essentially the same thing as acceleration. The only difference is that retardation slows down a particle while acceleration is often used to speed up the particle. And you have S is equal to 10 centimeters, and the initial velocity U is 200 meters per second. Final velocity V is 100 meters per second. Now, this question uses the third law of motion, which is V square equals U square plus 2AS. We can also write this as V square minus U square equals 2AS. So V is 200, so 200 whole square minus 100 the whole square equals 2 times acceleration times 10 centimeters, which is 10 divided by 100. So 200 square is 400,000. I mean, not 400,000, it'll be 40,000. Minus 100 square will be 10,000 equals 2a times 1 by 10. So 30,000 will be equal to 2a divided by 10. So therefore 2a can be written down as 30,000 into 10. So that is 300,000. And since 300,000 has 5 zeros, you can write it as 3 into 10 raised to 5, or for our calculations, we can write it as 30 times 10 raised to 4. 2a equals 30 times 10 raised to 4. A equals 30 by 2 into 10 raised to 4. 30 divided by 2 is 15. So the value for retardation, which we represent as A, is 15 into 10 raised to 4 meters per second square. Now note that here we use the formula V square minus U square equals 2AS. So using this formula is better because for retardation you would have to put a minus here instead of a plus, and that can create confusions in the formula. So V square minus U square equals 2AS is the correct formula. It's the same formula as the one we studied for the third law of motion. And using that formula and putting in the values of 200 meters per second, 100 meters per second, and 10 centimeters, you get the value of retardation as option A, 15 into 10 raised to 4 meters per second square. Now that concludes this episode of NEET Preparation. For more of our videos on NEET preparation, you can always hit the link in the description down below. For watching more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.